For starting with geometry semester 2, we're going to talk about what polygons are and some characteristics of polygons. The biggest thing about a polygon is it's going to have many sides. And it must be enclosed. That is probably the most important thing that makes something a polygon. So if something's not a polygon, it can be open. Also, if it's not a polygon, the sides can cross each other. They can cross over each other. So, giving you two examples of non-polygons, that would be a non-polygon, as would this. Those would not be considered polygons because they cross over one another. A polygon, by definition, is a closed plane figure, so it's completely enclosed, formed by 3 or more segments called sides. So it's got 3 or more sides. Each side intersects exactly 2 other non-collinear sides, one at each endpoint. So going back to this example up here, because this side intersects here, here, and here, that's where it talks about the intersects exactly 2 other non-collinear sides. That's what makes this not a polygon. Now, quadrilaterals are a specific type of polygon. Quadrilaterals have 4 sides. They're going to be enclosed. And no overlapping sides. So the definition is that a quadrilateral is a 4-sided polygon. And the prefix for quadrilateral means 4. So the last thing is a hepta. The prefix hepta in math means 7. So a heptagon has 7 sides. It asks for how are the names for the 10 and 12-sided polygons related. And a 10 and 12-sided polygon, a 10-sided polygon is called a decagon, and a 12-sided polygon is called a dodecagon. So they both have deca in it, which deca means 10. And then because it adds that do in front of it, do means 2. It asks us what are the prefixes hexa and octa. Hexa means 6. Octa means 8. Which polygon has the same name as a major government building? Well, hopefully you know that is the Pentagon. A 9-sided polygon is called a nonagon. And the only types of polygons that don't end with gons are triangles and quadrilateral. Okay, so it would probably be a good idea to write this down because you've gotten a lot of different names for shapes, but they didn't really go in order. So I'm actually going to write them in order. So we're going to start with a 3-sided shape, which is called a triangle. A 4-sided shape is a quadrilateral. A 5-sided shape is a pentagon. A 6 is a hexagon. A 7 is a heptagon. An 8 is an octagon. A 9 is a nonagon. 10 is a decagon. And the last one we have is 12, and it's a dodecagon. These are all of the ones that have special names. Now, they're not the only polygons that exist. So the way we name other shapes, like an 11-sided shape, would be called an 11agon. If we had a 25-sided shape, we would call that a 25agon. If we had 102 sides, we would call that a 102-agon. So anything other than these over here on the left, these have special names. Any other shape is going to be just the name of that number and then with the word agon at the end of it. Okay. So going back up to the part of your notes where it says page 12, when naming polygons, it says you start with any point or any vertex and then use all the vertex labels in order. So what they're talking about here is if I had a pentagon and these were sides A, B, C, D, and E, I could say this was pentagon A, B, C, D, E, because that means I started with A and went around this direction. I could also say that this was polygon C, B, A, E, D. So I could start at a different point and go the other direction. So it doesn't matter where you start, but you have to go in order. So something that it could not be labeled, okay, this is a not. I'm going to write this here, not. It could not be A, D, B, E, C. Because I do not get this polygon by connecting A, D, B, E, and C. It asks for 3 valid names for an octagon. Well, an octagon has 8 sides, so it could be A, B, C, D, E, F, G, H. That would be an option. It could also be H, G, F, E, D, C, B, A if I went the other direction. Or it could be D, E, F, G, H, A, B, C. Again, it doesn't matter where you start as long as you go in order. So moving on to the next page. It asks us, on the previous page, it actually asked us to write 2 valid names for this shape. So we can start anywhere we want. So we could start at X, and then we could go either direction. I'm going to go clockwise. I'm going to go X, E, R, B, O. That's one valid name. I could start at B, and I could go this direction, go counterclockwise, and I would get B, R, E, X, O. If you started at B and went the other direction, you would actually get boxer. So we have 2 different types of polygons that we're going to talk about. There is what we call a convex polygon, and there is a concave polygon. A convex polygon, the definition says it has no dents in it. A concave polygon has at least one dent. What that means is that a concave polygon means one side caves in, like this right here. This would be considered a concave polygon. So a convex polygon's not going to look like that. It's going to look more like what we're used to seeing, one like this. That would be a convex polygon. So concave caves in. A regular polygon is a convex polygon with all sides congruent and all angles. So when you put the word regular in front, what you're saying is that all the sides are the same, or all equal sides. That's what the word regular means in front of the word polygon. And the last thing is that congruent polygons. So congruent means 2 polygons that are the same size and the same shape. Congruent means they're equal. They have congruent corresponding sides and congruent corresponding angles. What this translates to is if I had 2 quadrilaterals We're going to pretend those are drawn exactly the same. And I said that they were congruent. Then that would mean if this side was 7, this side was 7. If this side was 9, this side was 9. And then whatever this angle was here would be the same as this angle. And the same thing with this one, and this one, and this one in the top right, and that one in the bottom. Okay, so if they're congruent, then all of their pieces are congruent as well. So looking at the checkup, we're going to do the odds as usual. Number 1 says which figures are polygons. So we have all these shapes up here, A, B, C, D, E, F, G, and H. And we're supposed to figure out which ones are polygons. Well, polygons have to have sides. They cannot be they have to be enclosed. It's also important to note that polygons can't have curves. No curves. So A would be a polygon. B would be a polygon. C would not be because it's curved. D would be a polygon. E, F, and G. H is not a polygon because it's not enclosed. Number 3 asks us which of these are convex. So convex, and remember concave means that it caves in. So convex means it doesn't cave in. Well, our convex polygons would be A, B. We know C is not a polygon. D caves in because it does this right here. E caves in, F does not, and G does not. So our only convex polygons are A, B, F, and G. Looking at number 5, it again asks us which of these are polygons. So A is not a polygon because it's not closed in. B is a polygon. C is not because it's round. D is. E is. F is. And G is. H is not because, number 1, it's not closed in. Number 2, it crosses. This time I'm going to do number 8 instead of number 7, so you'll have to do number 7. Which figures are concave polygons? So concave means that it has some sort of cave in, something like this, or which pretty much looks just like D. So D would be concave and F would be concave because they cave in. Number 9 says how many sides does a nonagon have? Well, you should have that list handy, and a nonagon has 9 sides.